Hello, everyone. Welcome to the Quality Gem track of TestCon Europe 2022. I'm Christina, and I'll be your host today and tomorrow of this track. Welcome, everyone. Thank you for joining. We start without further ado with our first session, our first gem. It's about testing a data science model, and our presenter is Laveena Ramchandani. She's one of the first people who ever spoken about testing data science models and data science in testing. And she, of course, believes that cost efficient test automation strategies are the best approach to ensure businesses keep pace with their market and avoid any major technology failures. The topic is extremely interesting. I will not bring any spoilers. I'll only want to remind you that our sponsors, Pact and Manning, will award the most active attendees who leave comments and rate sessions with free ebooks. So, Lavina, it's you now.
Thank you so much, Christina, and thank you so much, TestCon. So yes, without further ado, let's get started. I guess my slides are on the screen. There we go. Awesome. So yes, welcome everyone to my talk on testing a data science model. I actually started talking about data science about 2 years ago, where COVID started, and I thought I need to get out of my books and actually go out there and share the information that I'm learning myself, because it is super important. It is different. And I was thinking, if I am finding it new, how many people out there are not aware of either? So this is why I came up I made my slides, and I thought this is going to make a really good talk. And it actually was successful. And I'm continuing to share this information with all of you. So I really hope you enjoy today's session. So a little bit about myself. I actually graduated with a BSc honors in computer science. A little did I know about programming. The minute I heard Java, I freaked out. But today, obviously, learned and have knowledge of various different languages. And obviously, in the data science world, Python is the big one. So I fell into testing as well. My first ever job was offered to me, and I had no idea what testing was. So I just took it, and here I am after nearly more than 9 years, nearly close to 10 years now, where I am working as in the testing community and the testing world. So I currently work for EasyJet. I'm a test quality engineer manager there, and it's been an exciting journey. So I've been working for various industries, as you can see: oil and gas, transport, financial services, consumer goods, and now airline industry as well. And some of my hobbies include dancing, yoga, teaching, and baking. So in terms of today's tables of content, we are going to cover three main areas. What is data science model, which is the main important one. So I will take you over some background knowledge just to get you ready to understand what it all means and how can you actually apply your testing skill set to this area as well. Then the process, how to test the model. So there's various ways. Of course, every company has its own way, but the way I had learned, I thought is something that is transferable in other areas as well. And then some tips for you to take away and some complexities I came across and how I overcame those. So currently, 80% of the UK businesses are looking to hire data scientists or seek data consultancy, which is something that I keep hearing a lot out there. Every time I hear about data science, all I hear is a massive intake of data scientists. IBM also anticipates that data science will account for 28% of all digital jobs by 2020. And these are really interesting statistics. When I came across these statistics, one thing that made me think and open my eyes was, what are we doing to test this? Are we actually being involved in those teams, or is it just fully data scientists and no testers involved? So that's where I got more intrigued. And I was thinking to myself, right, I'm glad that I fell into a data science optimization type project. I'm going to try and make a way so that we have strategies in place, we have a plan in place to test, and we have the help of the data scientists to guide us to get there. So that's how I actually started. Okay, so the main important one. What is a data science? So, data science is a collection of tools and algorithms to unveil hidden patterns from raw data. It allows decisions and predictions to be made. The aim of making informed decisions, basically. Data science is more of a forward looking approach as well. It's an exploratory way with which you focus on analyzing the past, the current data. Also, the first buzzword for you today is predictive analytics, which I'll explain in a bit. But it uses predictive analytics, and organizations can look into patterns contained within data in order to understand risks and opportunities. So, when I was working in this area, we were trying to find more opportunities, how to make more revenue, how to basically go out to our client and optimize the model in a way so that we keep kind of improving their revenue, and so as we keep staying, obviously we are getting a revenue too, but how do we look at more opportunities with this big client? Okay, on to the next one then. So, what is a model? For the model, I thought I'll give you an analogy because I thought sometimes it's a lot of technicality. So I thought analogy might help stick in your mind what a model is all about. So imagine three things. You wake up in the morning and you're going into work, you're commuting, so you're going to drive. So your data is your driving experience where you're sitting into the car, you lock the car, you put the radio on, a bit of air condition. That's your data, right? Then you get into the road and then you're trying to find different ways to get into work because obviously there may be some traffic and you are trying to find the best way to get there, right? So you might come across traffic, you might have to take u-turns, you might have to wait for a bit until the traffic calms down. So your brain is trying different patterns, what to make sure to see what works best. So that's your computer side of things. Then we come on to the model side of things. So this is basically an equation of data inputs of how your inputs are being affected to the target value. In this case, the target value is how long it takes to get to work. So if you got to work in good time, your model's really good. You don't need to optimize it. But if it's taken ages to get to work, that means you need to work on your model, you need to optimize it and try and see better ways and quicker ways of getting into work. So that's how we literally work with models. I can also give you an example of a manufacturing firm. So you can check what they sold last week, for example, and check what if the same assumptions were used again, then what if the same assumptions were used again, then what would their future sale look like? So you can use your past data for your future data as well. Also, remember, a model is a statistical black box. So, models use probability distribution to understand behavior of its inputs. And it's more of a what if. So, if a customer uses the parameters that we suggest for that model, it suggests to the business what it could look like. So, just like the manufacturing firm, if we give them the parameters, then they know that they have an optimized solution. Also, your buzzword number two for the day is genetic algorithms. So, this is an algorithm that reflects the process of natural selection where the fittest individuals are selected. And this is inspired by Charles Darwin. So, model produces some indications that are being used as guidelines by our clients. And for us, we are testing against the expected outcome. we are also trying to test the model. So, trying to understand if the model said this is the target value, is it really the target value? So, that's where we come in as well. So, benefits of data science. So, as you can see, there's quite a few and more and growing. So, you can craft better decision making as a company. You can identify more opportunities, more business for your clients, actions based on trends to help define goals, data driven evidence, identification and refining of target results, and mimics real life scenarios. Okay, so obviously, because it's data science, a lot of data is involved. So let's have a look at some sort of data um, patterns here. So we've got structured, we've got semi structured, we've got unstructured, and metadata. So structured data adheres to predefined data models, easy to aggregate data from various locations and databases, easy to store and access and process, such as Excel files. It is very rare that in a data science project you see structured files. It's very rare. And then you have unstructured. It's a not organized or in a predefined manner. The data is not organized. Loads of irregularities, therefore quite ambiguous. An example could be videos, audios. That's your example. And semi-structured data is basically self-describing data, um, contains tags, markers, JSON and X. It's like a JSON and XML file. So slightly structured, which is what you're meant, which is something you'll see more in a data science project. And metadata, which provides additional information about data sets such as photographs, where it was taken, when it was taken, and can be considered as structured data. So it depends on what project you are. You will be faced with different types of structures of data and how you can use that to inject that into the model and see what the outcomes are. Okay, so I've drawn a little model out here for us, and I just wanted to take you over what a real model could look like. It could look as simple as this, or it could look a bit more complicated. So as you can see, you've got the database, you've got the logs, and you've got injections of data as raw data on the top layer, which is the data extraction stage. And then you have your features, which you're trying to run against this model. So feature extraction and pre-processing is happening. Then you have your learning stage. This is where your algorithms are playing the most important role. So your learning algorithms. So remember predictive analytics, which is something that I mentioned in the second slide or third slide. So I'll tell you what that is all about. Predictive analytics is the use of data and statistical algorithms and machine learning techniques to identify the likelihood of future outcomes based on historical data. So, organizations use predictive analytics to sift through current and historical data to reflect and detect trends and forecast events and conditions that should occur at a specific time or on supplied parameters. So, that is predictive analytics. So, that actually could be part of the learning algorithm area. Then you also have your genetic algorithms, which could also be part of this stage, or the model stage, where the model's actually being built with genetic algorithms. And then basically you apply all of this to a model and you get future like looking data. So a little bit of an idea of what it could look like. So I'll give you another example to make things more easier. So say if you're providing money on credit, like a bank, then the probability of customers making future credit payments on time is a matter of concern to you, right? So if I have a Amex card right now, the bank or the company would be concerned, isn't it, if I don't pay in? So here you can build a model that can perform predictive analytics on payments or on the history of your payments and predict if the customer will pay in the future or not. So these are things that actually banks use because when they're doing credit checks, they may have models running behind and just checking that this individual is going to pay us back, just like with a mortgage or any kind of money that we borrow from the bank. So think about it in that way. They also use some sort of process to understand if we are their right customers or not. Okay, the most important and the most interesting area of a project to be careful of, the elephant in the room. As you can see, everyone thinks the elephant is something else, right? Because it's a model, we can't visually see it. It's a black box, as I said, and it's all in the back end. We can't really see it. And it is something that can derail us. It can maybe make the testers find a lot of ambiguities, a lot of risks that we didn't think of. It can also deviate us, like, oh, we thought the feature was about testing this, but actually the feature is about testing something else. So I would say, please be involved from the very start as testers. Um, Whenever you have your planning or requirements session, be there, understand the problem, understand the data, be there in the be in the planning session where you're brainstorming possible solutions, right? When you brainstorm possible solutions, we are all talking, we are all trying to get on the same boat rather than have an elephant in the room. Whenever they're designing any prototype with the UX team or UI team, try and work with them as well. Again, when it's the decision which is the best design, be there as well, because as testers we have our views on things and we think differently. So use that skill set and give that feedback to the prototype team, the UX team, and then you can implement and then test. Obviously, I would suggest also play the three amigos here. It's super super important. Try to understand what is the problem we are trying to solve. um, how might we build a solution to solve the problem? So, for the development side of things, and testing wise, what about what could possibly happen? What could possibly go wrong? And how would you implement this product if this went wrong? So, start thinking of these sort of ambiguous ideas and risks to capture earlier. Okay, so let's get started. I'll show you the process that I was using when I was working at Deloitte. And I'd like to share this with you, and then you can actually see if this is something that would help you in your company too. So, a model could be off the shelf, or a model could be custom made. In our case, it was custom made. Therefore, the processes of testing should be made on depending on the above two statements. Consider how often you want to train your model as well. Basically, add data to it, run it, learn from its outputs. Also, understand that the model can be random or something called stochastic. So I'll explain that to you. 5 plus 3 for me and you is 8, but the model may throw 8.00000065. Do not worry, you just need to introduce something called thresholds, which would tell you, depending on the kind of business you're looking at, if it's something really critical like a bank, you want to keep your thresholds from 0 to 1% change only, or even less, 0 to 0.5% change in my values. But if it's something that it's not really critical, we kept a 0 to 5% change in results. If there was anything above 5% in our results, we would actually go and train the model again and sit down with the data scientists to understand what happened, what went wrong, and they would explain it to us. So remember, stochasticness, it can happen. Okay, so the process. Verify the data set you want to use for the model. Then check the shape. When I mean check the shape of your data, it doesn't mean by triangle, rectangles, or circles. It's testing the outputs. Will explain if the values are of the right type and the data columns are matching or not. And remember to use the threshold. So that's the validation of input versus output. Then test the areas that you are certain about and uncertain about with thresholds. So exploratory testing. Also, make sure no data has been dropped or no duplicates. So make sure that the data pipeline works as expected, because it can be dropped somewhere, but we need to understand what's happening. Where's the leak? Test using different parameters. Of course, we are testers. We love doing edge case style testing. So do that and do exploratory testing as well, because it's really interesting the things you find out. And explore the model. As the model can provide random results each time you run, and you brace the uncertainty rather than worry from the uncertainty. Try and understand if it's still okay to complete an anomaly and if it's really an anomaly or not. So it's a lot of is it or is it not? What if? So try and brace that. Okay. So some more details around testing. Um, if it's a new feature that you're testing in data science, work on a test plan with a data scientist. Consult the results with a data scientist for conciseness. It's good to pair with them. Logic is tested on unit tests. Make sure that the data scientists are writing unit tests because that helps. Run the model prior to a new feature. So if it's a new feature, see the results before it and see the results after it and see what difference did it make? How did it improve things? And of course, do exploratory testing. If you're doing regression testing for any release, then compare historic run. So have a delta run always ready from your previous release regression testing. And then have the new run with the new code and identify the trends and comparisons. Remember, some models can have randomness, which is fine. Just have a strategy in place for that. No equation for the best answer exists, so rely on a good enough and a fast enough result. Some questions for you to actually ask and think about when you're working with your team. What is an acceptable test? Because when you're in the planning session and there's a new feature, it's always good to open up because they'll help you to understand or they'll provide some guidelines to you as data scientists to help you run your test. Has a run completed and nothing broke within various stages of a model? So, data leakage, have we made sure that it's all okay? Have we found anomalies? Are there really anomalies? Did we drop some data somewhere again? How do we know what we produced is the right result? So, comparisons made between averages and sums. Try and do an average, do the sum of these results and see if you can compare it with a delta run. How accurate, obviously, how accurate are my results? Try and understand your confidence levels and precision from your delta run. So, this is something that you can always pair with your data scientist and learn more about this model. And what is an acceptable deviation? If we do go out of a threshold, is it still acceptable or not? Do we optimize or train our model and rerun everything again? So, things to question as testers. Now, I just want to give you a little, not a demo, but just a little practice, just so that you can start thinking about the data science model. Okay, these are some birds in some locations. So what we do is we take that data, push it into the model, and you get a dashboard of results. So questions we can ask here is, how many birds were counted on the seventh site? What is the total number of birds counted across all the sites? What are we actually expecting in site C in next month, next week, next year? So we are predicting now. We're trying to get the details. So this is how you would start thinking. Basically, I just wanted to give you a very easy analogy to start thinking of how we could play with the data. Okay, some complexities. Uh, Obviously, it depends on how your organization works and your data sets. How can we mimic the client data? So, of course, if you're using a client data, are we actually using raw data from them or are we anonymizing everything? If we anonymize, we need to make sure the files that they send us are equally sized when we are using them. If we're trying to anonymize, the file size becomes shorter. So, what are we doing to make sure that the files size are equal before anonymizing and after? So make sure you don't miss out these small technicalities. Understand the policies of using this data. Unless you make a golden data set that fits all your features, then that's the best position to be in. But this could also run out of date or be old data. Understand the model complexities. Of course, the model is going to be complex, but it's okay. It's fine. It takes time to understand a statistical model. Therefore, take time to pair up with developers and data scientists and data engineers to understand everything, such as how it functions, the data schema, what are the accepted data and what is not. Explore the model. It's a massive playground. You can explore as long as you're not playing in production environment. um, Again, knowledge silos, this can happen. So have some sort of place where you have your own data or information or logics explained. And remember on dependencies, if there's any dependencies to test a feature, make sure they're captured, because what happens is there might be a developer that has done his bit and we are testing it, but the data scientist actually didn't do his bit or her bit. So what happens is, we are testing, developers developing, and then we come to a point where, oh, this doesn't look right. I thought we were meant to change something here. So we have to go all the way back to just wait for the data scientists to do their bit, which is a bit of a time consuming act as well. So make sure that if there's anything dependency related, with the data scientist, with the developer, with a tester, with an analyst, with a product owner, it's all captured earlier. It's all on your ticket, so it's all clear. Okay, some useful tips then for all of you before I end the session. Understand the data from the business point of view. Don't derail. Make sure you stick to the consumer requirements. Review and analyze specifications, define test scenarios, execute test scripts, review them, and make your reports. Remember, your model mimics real life scenarios with tons of assumptions. Assumptions limit scopes, so you can't pick all assumptions realistically. And sometimes they can also get complex and interfere with what needs to be delivered. So be ready for discrepancies. By providing statistics and facts for employers and customers, what you're doing here is making a savvy team and smart team that can use these insights to drive more business. And once you have a process within the team, stick to it and look of better ways to optimizing it. So it's not just optimizing the model, it's optimizing our teams as well. Okay, be present at all meetings. I know they will be technical, but it's okay. We don't need to know everything. There's millions of algorithms. Pairing is super useful. Raise your concerns always. Make sure new features are being released often and bugs are not repeatable. So, what does this leave me with? We are a tester. We learned data science validation, making us a hybrid tester. So, a quick glance over the tools that I used. I used SQL, statistics. You don't have to be a mathematics pro. Data scientists can also support you. Have Excel, so you can do your sums on there, averages, to everything, standard deviations, everything. You use your dev tools if you're using front end, and Miro to collaborate as much as possible. Perfect. Thank you very, very much. But just a little summary. So remember, edge case testing and exploratory testing are a must here. Make sure the model accuracy and precision metrics exists, and make sure model can perform at a scale with new features and is maintainable, and you can get the results that you want for your clients. So thank you very, very much, everyone. I hope you enjoyed the session. Of course, if you have any questions, feel free to ask me. I can see a question, but feel free to connect with me on LinkedIn and Twitter. I've also got blogs on Medium, so feel free to read those. I do keep posting a lot. Yeah, thank you very, very much. And I hope you really, really got some insights out of all of this.
Thank you, Laveena. Thank you so much. Data is, I believe, data is one of the underestimated topics in testing. So thank you so much for that. We start today with data. Data should be always our consideration in our test, whatever we are testing.
Yeah.
Software development is about manipulating data, and we kind of leave it aside. So thank you so much. It was extremely insightful. We have one question from Erhan Tayar. Have you had any studies that test automation reduces the number of incident problems?
Okay, yeah. So obviously, there's every organization varies. When I was working on the data science side, it did reduce incident problems in the point where we had to anonymize data, because what was happening is we started anonymizing client data manually. And of course, we can miss a data or two here and there, isn't it? There's no way we can copy the exact things. We were trying our best as testers, but obviously it was getting very hectic, because every 6 months or 3 months the client would change their data. They have new patterns, new trends, because they're selling. All right, because they're a factory, they're selling in different countries, and they send us new files, and we want to also refresh our model to train it. So what happened was we automated the anonymization of those files, which were about 18 to 20 files. And we felt that this was a 5-minute task, whereas we were spending a half a day anonymizing client data. This reduced a lot of risks, and we didn't find any incident. Before, we were finding incidents uploading the file because of the file size is varied because of anonymization. Um, all sorts. We were finding a lot of data issues, but I thought automation really, really improved things. And of course, there's only so much automation you can do for a predictive analytics or genetic algorithm model, because certain times you just want to do exploratory testing. And you can, of course, automate your exploratory testing. But I would suggest, of course, you can do automation, but I would say start manual and build up on it into automation, because you will learn the nitty gritty details of this model initially, and then you know exactly how to automate your features and your scenarios, and it will become easier. So that's the kind of answer I'd give for question number one. Question number two, I can see as well. Any books or blogs or YouTube channels? I would suggest read my blogs that I have written on data science. There's more details. Deloitte actually posted it as well. So have a look at that. Of course, you can learn a bit of data science on Pluralsight, on any YouTube channel. Learn the basics. Try and understand, because we are testers. We think differently to data scientists. So it's good to keep our skills and use it with them. So I would say read up on data science, try and play with data and see what you think, see what results you get. What is the story behind this data? Why are we doing this? Try and understand from the very basic details, why am I trying to help this company? Or why am I trying to run this model? What is it doing really? So if you understand the basics, it makes life easier. So that's what I would say. Okay, we've got another question from Vanessa. Depending on the problem, the outcomes of a genetic algorithm can sometimes change a lot. Yes, 100%. It might run into local optimum. Do you determine the thresholds you use for testing based on the problem? Do you adjust? Do you by default rerun tests a few times if there is an expected variation of outcomes? So, what we did was we had a defined threshold, 0 to 5% variation, we can go ahead. But if it was above 5%, we would stop and rerun. We would like to train the model again to see, why did this happen? Why haven't we picked this issue before? Is there some sort of problem? Is there a bug in the model? So we would go in the most simplest way possible. So we didn't have any adjustment there, but we wouldn't run various tests either. We would try and analyze why this variation happened, and try and get to the detail of this model. And then once we know that, oh, there is something, or no, there's nothing, try and run again. Maybe the parameters are a bit off. So that's when we would basically rerun, and then we would aim to get the right results. It was more of the simplistic side of model testing. So I hope, Vanessa, I answered your question. Then we've got a question from Mick. Um, how do you determine the thresholds for your tests? So every time I had one data column always changing. This was one parameter that would always come back very different. So I did speak to the data scientist. I told them I'm extremely confused. how to pass my testing, because every time I run the test, I see different results. I'm not saying this is wrong, it may be right, but I need you to help me to understand this. So it's just pairing with them, it's just understanding how they're working. How is this feature impacting everything else? And not just talking to them, talking to the entire team, raising your concerns, because it can be confusing for testers to see different results every time. So what we did was I told them that can we not just do some sort of system where if the values are above a boundary, we look into the model because something may be wrong. So that's where we came up with thresholds, and we decided because it's not a bank or a critical monetary system, we'll keep the threshold 0 to 5%. But of course, if your system's more critical, you need to think better. Smaller thresholds would be much better for you. But make that's the way we determine our thresholds. It was through a meeting, planning sessions, made a strategy, put it on the Confluence page, made sure everyone knows, and made sure we were clear about it with everyone. So hopefully that answered your question, Meg. From Dustin, uh, did you ever have a database system to test with a quality or so bad, so structure so bad you had to reject it? Oh, okay. Not really. I think it all depends on your data, isn't it? The structured, semi-structured, unstructured data. So it all varies on that. So there were confusing times at the start because everyone was trying to learn from it. But we tried to jump onto JSON files because the data engineer thought this is going to help and it's going to make things easier. So the data engineer said, let's stick onto JSON files. It's more self-explanatory, it's more structured. And that's what we used to send to our clients to actually send their data in JSON version, and they would start doing it. So we faced a bit of ambiguity at the very start, but then we resolved it. So that's that. From Naila, how do you go about if your team does not have a data scientist? Does the work fall on developers? So, Naila, I think data scientists are specialists in this area. Developers are specialists in their area, and we are specialists in our area. So, I think it's important that if you are building models, how are developers building this model? Do they have data science background? Have they worked in data science before? If so, then they would understand how this works. But if not, I think a data scientist would be vital because they study this. They study this in and out. So they would be able to give us the best kind of model, the best kind of algorithms out there possible. And all the algorithms we used are out there on Google. You can search them. So that's how I would say. And make sure you communicate with all of them actually as well, because different opinions will give you different ways of thinking and maybe make your ways of testing things easier as well. So I hope I answered that. And number 8, we've got a question from Alexander. What types of errors did you have encountered by testing data? What are the classes of bugs? Are there any? Is it useful to categorize? And how do you prioritize the bugs? So we had loads of bugs, right? Because data was obviously mismatching. Um, Sometimes the model would throw errors, so that would impact our testing. So that's where the structured and unstructured file came handy. When the JSON files were created, it made life easier. Other issues were when we were anonymizing our data files from the client. When you anonymize, your file size becomes half the size and the client size stays the same. So when we try and input these files into our system, it worked wonders because it was a smaller file. But when the client was doing this, they saw an error. They said, for some reason, there's an error saying your file's too big. So then I was like, but we ran it and it looked fine. But then we realized soon that we have anonymized data. So the file size is half the size. And they're using their real data. So the file size is double the size. So that's where we understood a developer made a change into the input system and put a limit of the file size that can go in. And no one knew about it. It was a silent development. It just happened and that's it. So we were all confused. And then we were like, communication is a must. So talk about it. If you've changed something in your team, say it loud and every day, because you never know what you might encounter and you may delay the processes elsewhere. So yeah, we did have those kind of bugs. We had a lot of accessibility bugs because it was front end, and loads of like aesthetics bugs, like something, the color looked off, buttons were not the same style when we wanted to upload things. Parameters, like the fields and the parameter names were stuck together sometimes. The others would be fine, it would be just one just stuck there. So yeah, there's like from the easiest of bugs to the most complicated of bugs when it comes to data. So there's a good variety, good selection. It's just like a chocolate box. So yeah, I think those are all the questions.
Awesome. I think this has been our questions. We are so on time, of course. Talking about efficiency, we were very efficient. Thank you so much, Laveena. I loved to end the session with communication is the key. We can continue starting and ending talks with communication is the key. It's the key to any sort of testing and delivering high quality. Thank you
Yes.
so much. Thank you, everyone. We'll see you in the next session where we're going to talk about why working with production data is not a good idea. And Laveena already warned us about this. Thank you so much. See you in the next session.
Thank you so much, Tescon. Bye bye.